Good morning, finance class. So we are going to cover 4.8, and I have written down some conversion data that you're going to need to know. Most of this is in the book, but when you go to do your homework, you'll need to have these written down somewhere. So if you want to pause the video, please note MI is for mile, KM is for kilometer, and just M would be for meters. And so I've written the conversions from feet to miles, meters to kilometers, meters to feet, kilometers to miles, so that you have that there. Now let's go over some formulas or some data that you're going to need to do this section. So this section covers like our reaction time in the case of an accident. So there's reaction distance, there's braking distance, and then the total stopping distance. So reaction is basically how long it takes for us to react. And so typically it is 1 foot for each mile per hour of speed. So if you're driving 60 miles per hour, you would need 60 feet for a reaction distance. The next piece is your braking distance. So that's based on how fast we're going divided by how fast we're going squared divided by 20. And then finally our total stopping distance. So our total stopping distance takes into consideration our reaction time. Plus, once we hit the brakes, it still takes us several feet for our car to come to a complete stop. So our total stopping distance is the two added together. So we're going to do a bunch of examples today practicing all of this. So I can attach a blank copy of this if you'd like to fill it out with me in this video. All right, so number 1, how many miles does a car traveling at 57 miles per hour cover in 1 hour? So this is asking if you understand this. 57 miles per hour means I will cover 57 miles in 1 hour. Okay, and so just understanding what that means. It means that in 1 hour I will have traveled 57 miles. So the part 2 is having us convert this to feet. So how many feet does a car traveling at 57 miles per hour cover in the following? So in 1 hour. So I'm going to set this up. I have 57 miles, okay, per 1 hour. And they want me to convert my miles to feet. I'm keeping the hour because it says 1 hour. I'm keeping the hour. So in the beginning of our notes, I wrote that there are 50 to 80 feet in 1 mile. So I need the miles to cancel. Whenever we're converting, we want to get rid of miles, so miles over miles cancels. And then on top, I'm going to write how many feet there are per that 1 mile. So I have this, that's all I need. Notice I'm left with feet per hour. So I'm going to multiply the top, right? 57 times 50 to 80. The only thing I have on the bottom are ones. So I'm going to multiply that. And I got 300,960. And notice I'm left with feet per hour. So this is feet per hour. Now this says how many feet in 1 minute. Okay, so let's start with what I have for how many feet in an hour. So we start with what we wrote in part A. So this is feet per hour. Okay, this means I covered this many feet. Whenever I say per, it's a single. So this is per 1 hour. I need to convert this to minutes. So we should know that in 1 hour, I set this on top because they only cancel if one is in the top and one is in the bottom. And I know that in 1 hour, there are 60 minutes. So notice I have what I want left. I have feet per minute. If I multiply straight across, I'm simply dividing 300,960 by 60. And that gave me 5,000, whoops, I wrote that wrong. 5,016, I'm left with feet per minute. So that means that's the amount of feet I'm covering in 1 minute. That's how you read that. All right, now it says how many feet are covered per 1 second. So if I covered this in 1 minute, I would simply divide, right, by there are 60 seconds per 1 minute. So that's another way to set that up. There are 60 seconds in 1 minute. The minutes canceled. Notice I'm left with feet per second. So 5,016 divided by 60, I have 83.6 feet per second, based on the fact that I'm only going 57 miles per hour. Faster you go, the more distance you're covering, right? I'm going to go ahead and skip number 3 and 4 because they are identical to that problem. All right, so now let's do this algebraically. So how many miles does a car travel at A miles per hour in 1 hour? It would travel A miles. So I'm doing number 1 and 2, but algebraically. How many feet does a car traveling at A miles per hour cover in the following? Well, it'll be A, whatever the amount of miles is, times 50 to 80. That's what we did up here. Notice I took the number of miles times 50 to 80. So instead of writing 57, I'm replacing that. So this can be written as 50 to 80A. All right, now the next thing I did, per 1 minute, well, I'd have to convert this to minutes. So 50 to 80, if that's 1 hour, I'm dividing by 60. It's the same that we did in part B. I divided by 60. Part C, I divided by 60. So I'm going to reduce this. I divided my numbers, and I got 88A. So what about 1 second? Well, I would take the last answer and again divide it by 60 because there are 60 seconds in 1 minute. And I'm going to reduce. So I divided the top and bottom by 4. And so I got 22 over 15A. Or if you wanted to make that a decimal, I would do 22 divided by 15. So I got about 1.5A. It's up to you. I'm going to leave it as a fraction. It's more accurate. All right, now we're going to be dealing with kilometers. So number 7, how many kilometers does a car traveling 50 miles per hour cover in 1 hour? And let me make sure that that is not a typo. Sorry, this should say kilometers per hour. That's my bad. Okay, so how many kilometers does a car traveling 50 kilometers cover in 1 hour? It travels 50 kilometers in 1 hour. How many meters? So they're having me convert my kilometers to meters. Does a car traveling at the same speed, 50, this should say kilometers per hour. Oh man, I have typos all the way through, so I will fix that before I post that. All right, so per 1 hour, I have traveled 50 kilometers in 1 hour, and now we're going to use our conversion that I wrote in the beginning. 1 kilometer, kilo, represents 1,000, so 1 kilometer has 1,000. So 1 kilometer, or 1 kilo of meters, is 1,000 meters. So kilometers cancel. I'm left with meters per hour, which is what they wanted, meters per 1 hour. So I'm multiplying 50 times 1,000, and that gave me 50,000 meters per 1 hour. So that's 50,000 meters in 1 hour. Now, if I'm converting that to 1 minute, do you remember what I do? I have 50,000 meters per hour. I have to convert that. There are 60 minutes per hour. So the hours cancel, and I'm left with meters per minute. So 50,000 divided by 60, I got 833.33 meters per minute. That means I'm traveling that many meters in 1 minute. And then to convert that to seconds, right, I have 833 meters per minute, but I know that there are 60 seconds in 1 minute. So minutes cancel. I'm left with meters per second. Divide, and I got 13.89 meters per 1 second. All right, so let's now do that algebraically. So a car traveling that's a subscript, so it's slightly slanted, would be A meters. Whoops, A kilometers. So in 1 hour, remember I would have to take the number of, there are 1,000 times A. That's what we did in part A. We did 1,000 times the number of kilometers, so 1,000 times A. In 1 minute, we took 1,000 times A and we divided it by 60. And that gave me 50 over 3. And 1 second, I would take 50 over 3 and divide that by 60. So that would give me 50 over 3 times 1 over 60. So that gave me 50 over 180. Reduce that, 5 over 18A. Okay? Now, I will fix those typos, but let's move on to number 11. So remember, braking distance, I wrote in our notes, is 1 foot per mile per hour. Braking distance, it should be the speed squared divided by 20. So I wrote those here. Reaction distance is 1 foot for each mile per hour of speed. Braking distance is our speed squared divided by 20. So we're going to do that for the following table. So if I was driving at a speed of 75 miles per hour, it would take me, my reaction distance is 75 feet. So notice the numbers match. It's a foot per mile, so since there are 75, that'd be 75 feet. My braking distance should be 75 squared divided by 20, and you would simply enter that in our calculator. So 75 squared divided by 20, and I'm going to round to I'm going to leave it to the nearest hundredth. So this is 281.25 feet. That is how many feet my brakes would need to stop. So if you added those two together, that'd be your total stopping distance. It would take 75 feet for you to react, right? We don't react right when we see something. It's like we see it, and then our brain processes it, and then boom, we react. And then this would be how long it takes your brakes to come to a complete stop. So this next one, the same thing. If I'm traveling at 65 miles per hour, it would take 75 feet for me to react. My braking distance would be 65 squared divided by 20. So 65 squared divided by 20, and I get 211.25 total feet. So these added together would be your total, almost 300 feet. Next one, 55 feet. This would be 55 squared divided by 20, which gave me 151.25 feet. So hopefully you're noticing the slower that you're driving, the less feet it would take for me to react and brake. So next one, 45 feet. This would be 45 squared divided by 20, which gave me 101.25 feet. Last one, if I'm only driving 5 miles per hour, it would only take 5 feet to react, and my brakes would only need 1.25 feet to come to a complete stop. So the faster you're driving, the longer it takes for your brakes to come to a complete stop, which is kind of common sense, but. All right, number 12. So now let's talk about real-world scenarios and when they're investigating our car accidents and figuring out how fast we were driving and if we have enough time to stop. So this says, hold on. Jerry is driving 35 miles per hour as he approaches a park. The dog darts out into the street between the two parked cars, and Jerry reacts in 3/4 of a second. Please know that's not really important. So this is not really important. What is his approximate reaction distance? Remember, it's 1 foot per mile of speed. So since he was going 35 miles per hour, he would need 35 feet to react. So it should be the same number. Number 13. All right, so he's driving in a zone he is driving 60 miles per hour on a state road. Here's my speed limit. He sees a fallen tree up ahead and must come to a quick, complete stop. What's his reaction distance? Well, it's going to take him 60 feet to react. His braking distance, remember, is his speed squared divided by 20. So in my calculator, 60 squared divided by 20, I get 180 feet. About how many feet does the car travel from the time he switches the pedal until he's come to a complete stop? Well, you would add it. 60 to react, 180 for my brakes to completely come to a stop. I would need 240 feet, or he would need that many feet to not hit the tree. Number 14. All right, so Anita is driving on the highway at the legal speed limit. So she's driving at 63 miles per hour. She sees a police roadblock about 300 feet ahead and must come to a complete stop. Her reaction time is 3/4 of a second. Is she far enough away to come to a complete stop? All right, well, let's figure it out. I would need 63 feet of 63 feet would be my reaction distance. Plus my braking distance. And so I'm going to enter that in the calculator. 63 plus, and then in parentheses, 63 squared divided by 20. So she would need 261.45 feet to stop. So, is she far enough away? Well, this says it's 300 feet ahead. She only needs 261 feet to stop. So yes, she is far enough away to safely stop. All right, last one. Rob is driving at 63 kilometers per hour. He sees an accident 30 meters ahead and needs to bring the car to a complete stop. His reaction time is 3/4 of a second. Is he far enough away from the accident? All right, so first, I need to know, I'm going to convert this. I believe we had to convert this to miles per hour because I need to get it to feet, right? Because stopping distance is in feet. So I have to convert this as 63 kilometers per 1 hour times. There is 0.621372 miles per 1 kilometer. So I'm going to be multiplying 63 times that long decimal, but it's important to make it accurate. And I get that he's traveling 39.1464 miles per hour. So now that I have it in miles per hour, I can calculate my reaction distance plus my braking distance to give me my total. So reaction, it would be the same number of feet, so 39.1464 plus, right, I'd have to square that long number and divide it by 20 and enter that in my calculator. Make sure you put this in parentheses. And I got 115.77 feet. Now, it says it's 30 meters ahead. So I need to convert 30 meters to feet. So 30 meters times, there are 3.28084 feet in a meter. So that's 98.42 feet. That's how far ahead that the accident is, but he needs this amount of feet to stop. So, no. Rob does not have enough room. Meaning he's probably going to run into the accident, which is how you get in a big accident on the highway, a pileup, right? Is because we don't have enough distance between us and the car in front of us to come to a complete stop. So that is the last problem of this section. So this answer is no. Thank you.